The next force we're going to talk about is what's called the normal force. Now, normal, not because it's normal or average or anything like that. We refer to it as a normal force because of the mathematical relationship. When you talk about mathematics, you can create a plane, and to describe that plane, you can create a vector, an arrow, pointing up or down that's perpendicular to that plane. Okay? That's what we refer to normal. It's always perpendicular to that plane. It's perpendicular to a surface area. So what I have here is I have a table and I have a book sitting on top of that table. The book is being pushed down by the force of gravity. It's pulling the book down towards the earth. Okay? So that book is exerting a force on the table. Okay? So it's applying a force on the table. The table in turn responds to that with a normal force. Now, obviously the arrows aren't quite the right length. Let's think of it this way. If I apply a heavy force down by the book, it applies a heavy force back up by the normal. Now, you may look at this model and go, hey, look, the normal force is nothing more than a response to the force of gravity. That's not always true. Take this exact same situation where I'm applying a normal force, or I'm applying the force of the book, but then I put a hand on there that's going to apply a different force down on there. Not a very good hand, but oh well. Here's my hand pushing down again on that book. Now it's not the weight of the hand that's pushing down. It's just I am going to use some muscle and I'm going to shove that book into the table. So I'm applying more force. Well, the force that's applied down may be something like this. So I have the force of the weight of the book itself, the force of gravity, and this additional applied force that's pushing the book even further down. Okay, the normal is that force that responds to that. So it says, how much are you pushing down on me with? And I will respond with exactly the same amount of force. Okay, so if I'm pushing down with this, looks like my arrow is going to go something like that. It's going to respond with exactly the same amount of force. It says you've got 20 newtons down, 10 and 10, or 15 and 5. I'm going to respond this way, perpendicular to the surface, with 20 newtons. It responds with the exact size. Now, once again, we go back to that idea of what normal is referring to. It's always a vector that's pointing up perpendicular to a surface. Okay, so when we refer to the normal force in this case, the normal force has to be perpendicular to the surfaces that are in contact. So this book and this table, when they lay on top of each other, those are the two surfaces that are in contact. The normal is going to be perpendicular to that. Okay? So that's normal force. It's a reaction force. It's a responsive force. You apply a force on an object or on a surface. The surface replies back with what's called the normal force. It's a reaction. So it doesn't have a mathematical equation. It responds simply with the amount that it needs to respond with, or up to a point where, in that case, it breaks. But it responds to as much force as it needs to. Okay? The geometry, though, is always going to be perpendicular to those surfaces of contact. Now, in this case, it may not look like a big deal, but what happens if this is a slope table where the book is being pushed down like this? Let me erase that so we can clear off some space. So instead of sitting on a nice flat surface, if it sits on a surface like this, here's my book. Okay. The normal force has always got to be perpendicular to those to that area that's in contact. The book surface, the book cover, is in contact with this ramp. The normal force has to respond with whatever force is needed perpendicular to that surface. It always has to be perpendicular to that surface. Now, if we were talking about weight, weight is in this direction. So this normal is responding to that weight. But it always has to be perpendicular. Okay? Always perpendicular surface, and always as much force as it needs to be. Those are the things we have to know about normal. And it's a reactionary force. It responds to a force. It's like, if you're going to apply this much force down, then I will respond with exactly that much. So, no equation, perpendicular to the surface of contact. That's normal force. Okay?